When you call a function, the function might take up some arguments. This video will be about passing argument down to functions. I'm going to delete all this code here and keep the variable age here. Let's define a function named hello void hello. And let's say this function takes up one argument, and the type of this argument will be an integer data type. I'm going to say an n. Then we're going to print the value stored in this variable n. What happens when you define a function like that? When you define a function, a function has what we call a scoop. All variables defined in the function are in the local scope, meaning that they can't be used or accessed from outside the function. A possible way to change the values may be to pass down to the function an initial value for these local variables. For example, I can call the hello function like that by passing the value 15. Let's see what's going to be displayed in the terminal. GCC store.c, the output file program. The output file name will be program. Then let's run the code. And we see n equal minus with a big number. Oh, yes, there is a mistake in the code. I'm going to add the n. And here we have n equal 15. What happened when you call the hello function? When you call the hello function, this n variable is declared and the memory location is used for this n variable. I'm going to go on the right side and type in n. It represents a memory location that has an address and a data field that can store integer data types. So when you call hello, the hello function, then you pass in the 15 or the integer value. What's going to happen is the memory location represented by the variable n, the data field will be set to 15. Then you can display it inside the the hello function. What if I just take in the age variable, I pass it in here. Let's set the value or assign a value to the variable age. I'm going to assign 111. Then pass hello to this, pass the variable age. What is happening is when you type in the name of the variable, you're telling the compiler you want to get the value stored in the memory location represented by the variable age. So I'm going to type in on the right side, age, represent a memory location that has an address and a data field, which is an integer data type. Then the current value stored in that data field is 100. So by typing age, then the compiler will simply say, okay, we are going to copy the value stored in this memory location, which is 100, then copy it into the memory location represented by the variable n. So the value stored in the variable n now will be 100. Let's compile this code and see. Here we see n equal 111, 111. Oh, yes, we should type in here 111 and 111, okay. So basically, this is it. Whenever you declare a variable, you can change the data stored in the memory location represented by that variable. Now, what happens when you want to pass in, for example, or let's say you want to let the hello function to be able modifying the value stored or to access the age memory location. You can pass in the address. If you pass in the address, then inside the hello function, you can use the dereferencing operator on the address to get access to the memory location represented by the variable age. So I'm going to delete this function name and change some other things here. Let's define two functions. The first function name will be print age. So this function defines a local variable named n. Then we use the print f function to pass in the value of n. Then we have the print age function displaying the value stored in the memory location represented by the variable n. Now let's define another function named change age. This change age function will simply modify the value stored in the memory location represented by the variable age. So let's say this function has an argument that can receive addresses, because only when we have to have a variable that has a reference to the memory location we want to modify. Let's type in P, and then the star sign tells that this variable has a memory location that can store addresses. What type of address? The type of data stored in these addresses are of integer data type. Now, inside the change age function, we can use the dereferencing operator to let the compiler know we want to change the value stored in the past value. Let's say we type in the dereferencing operator, then we use the assignment operator, then we type in the value we want. 65, 69. Now I'm going to delete this code inside the main function and set the value of age to 10. Then we call the function print age by passing in the value age. By passing the value stored in the age memory location. Then we call the change age function. Here, the change age function the data type received by its first argument or its first local variable defined as an argument is an address, and the address that it can receive is of type integer. So when instead of passing the value stored in the age memory location, we want to pass in the address of the memory location. Ampersand sign age. Then let's use the function print age again to display the value stored in the variable age. Remember, when I say the value stored in the variable age, I'm actually referring to the value stored in the memory address that age represents. Let's compile this code and see what happens. I'm going to delete some blank lines just to make the code shorter. Inside the terminal, type in GCC, the start sign C. The output file name will be called program. Then let's run the program and see. So here in the terminal, what you can see, you see that the first thing displayed is 10, then 65, 69. I'm going to clear the terminal and run the program again. Let's analyze this code on the right side. When this program starts, a variable age is declared, which means a memory location will be allocated to our program, and we can refer to that memory location using the name age. The data stored in that memory location can be an integer data type. Then on the next instruction, we assign a value to the variable age, which means we want to update the data stored in its memory location. The data will be set to 10. Then we call the print age function. The print age function defines an argument. The name of the argument is n. So a memory location will be assigned, allocated to our program. The n variable also has this memory address, which has this memory location, and the data type for that memory location is an n. Then what the program will do, this will tell, okay, we want to copy the value stored in the memory location represented by age to the memory location represented by n. So this will do 10. So we'll have 10 here on the second line. Then the printf function is called, which displays 10. Now the second call here, we have change age. The change age function define a variable named p. The p variable now represents a memory location that can store and address data. So on the right side, we type in p. So p represents a memory location that has a data field that can store addresses. So we type in the start sign. The addresses the data field can store are of type integer, meaning that this memory address can store the memory, let's say, which means that this memory location can store data or can store addresses for, let's say, this memory location represented by age, which is an int type memory location. So by calling the function change age with the ampersand sign age, this tells the compiler, I want you to pass in the address of the age's memory location. So if the address is, for example, let's say 0x0FFA, then the value that's going to be copied in the memory location represented by P will be equal to 0x0FFA. This is just an example, but these addresses can change whenever the program restores. Now, inside the change age function, we use the dereferencing operator to tell the compiler we want to access the memory location represented by the value stored in the variable P. So this will be like typing zero. When you type in P, let's say when you type in P, this represent the value stored in P, and the value stored in P is 0x0FFFA. Then by using the dereferencing operator, we telling the compiler to look inside the memory, which address is, which memory location has this particular address. And the memory location we're looking for is the age memory location. Then we tell the compiler we want to assign 65, 69 to the data field of that memory location. Which is going to, let's say, this is going to say, okay, we're going to assign 65, 69. Then the change function is terminated. Now the second print age function, we type in age, then what's going to happen again is the n variable memory location is going to be defined. Then the value stored in the ages memory location currently is 65, 69. So the n variable will receive for data 65, 69. Then what's going to happen in the print age function? The print age function will use the printf function to display 65, 69. This is what we see in the terminal 65, 69. So here, what you understand is that pointers are not magic. Pointers are simply variables, and those variables can be used with the referencing and dereferencing operator. This is all for this section, the function calls and using referencing and dereferencing operator. The next video will be a bonus. We're going to see how to declare arrays and how arrays works. Then we're also going to have a look at dynamic memory allocations. The next video is only a bonus.